Hello, we have learned the equation of a line and the equation of a plane, and in this lesson we are going to see the intersection of a line and a plane. So it will have several case possibilities. One is just intersect at one point. So this is a plane and the line will just pass a plane, and you have one point of intersection. And the second possibility is you have infinite number of solutions when it happens that the line is just on the plane. And the third possibility is you have a plane and the line is parallel with the plane but not on the plane. Then it means you have no solutions, no point of intersection. And the second one, you have infinite point of intersection, and the first one, you have one. So the example. So example 1, determine the following lines and planes intersect, if they intersect or not. If you have one point of intersection or zero intersection or infinite. So the first one, you see x, y, z in one equation. And that is our ax plus by plus cz plus d equals 0. So this is our equation of a plane, Cartesian equation of a plane. And the second one is parametric component vector equation. And in this equation, you will see only have one variable t there. So it's kind of, you have r equals r0 plus ta. So this is one point and one direction vector, so that is a straight line. So the second one is a straight line. And now if we have another variable, it will be the plane. Okay, so this is a equation 1 is our equation of a plane, and for the equation of a line, you have 1, 2, 3, 3 equations. And if we substitute the x, y, z to the first equation, we are able to have one variable in one equation, and that is what we want. So one variable in one equation. So we are going to sub x, y, z into equation 1. The reason for that is our goal is one variable unknown in one equation. So we substitute them into equation 1. We have 5 times 5, 9 times 5 plus 2t plus 13 times -5 minus 5t. Then minus 2 times 2 plus 3t equals 29. So this is an equation with only t as unknown. This is a linear equation, and we are able to solve a linear equation by isolating the t. So we are going to get rid of the brackets and collect the like terms. Then we keep t at one side and move numbers to other side, doing opposite operation. So now we are going to get rid of the bracket by expand. The reason why we want to do it, because we want to collect the like terms. When the terms in bracket, we are not able to collect them. So 45 plus 18t to 9 times 2, then 13 times -5. -65, then minus 65t. Minus 2 times 2 is -4, then minus 6t equals 29. Then we are going to collect the like terms, put all the t together, and move all the other numbers to other side. So 18t minus 65t minus 6t equals 29 minus 45 plus 65 plus 4. Then we have negative 53t equals negative or positive 53. So we want to isolate t. We move the negative 53 to other side by doing opposite operation. We have t equals 1, negative 1. So, and what it means, if we sub the t equals negative 1 back, we are able to find the point of intersection. So the question didn't ask you, but I want to show you what it means. So sub t equals negative 1 back into x, y, z. So x equals, y equals, z equals, because t exist. So then we have x, y, z exist. That is a point of intersection. So 5 plus 2 times negative 1 give us 3. Negative 5 minus 5 times negative 1 give us 0. 2 plus 3 times negative 1 give us negative 1. So the point of intersection is 3, 0, negative 1. So therefore, the line intersects with the plane. So this is our first possibility. First possibility is just one point of intersection. And we are going to see another example, example 2. So it asks you, this is a line is in the plane or not. So for such question, we want to write the parametric equation for the line out. Then we have x, y, z, then we can sub it in. So what if the plane is not given in this Cartesian equation? If the plane is given in the vector equation, then what we want you to do is cross multiply the AB, find the normal, then from the normal, this is ABC, subbing the point x0, y0, z0 to the Cartesian equation. So you have 7 letters here, you sub in 6 of them, then you can solve for D, then you can convert the vector equation to the Cartesian equation, then continue go from there. And if the equation is not given in this Cartesian equation form, but given in the parametric equation form, so it's x0 plus sa1 tb1, then y equals y0 plus sa2 plus tb2, z equals z0. So tb y direction, z equals z0 plus sa3 plus tb3. If it's given in this parametric equation form, then what we can do is find the x0, y0, z0, then from the A and the B, find the normal, then go back to this equation, sub in the normal ABC, x0, y0, z0 to find the D, then convert it to this Cartesian equation, okay? So if not given in this equation, we want you to just change it to this equation because it's easier. Then with sub x, y, z, we could solve for the unknown. So from the equation of the line, we can write it in the component vector, the parametric equation form. So x0 plus s times a1, so it's plus s. Y is 11 plus 5 times s. The z is 2 minus 2 times s. Then we sub x, y, z into the equation. We could call this one 1. We have 4 times 5 plus s minus 2 times 11 plus 5s, then minus 3 times 2 minus 2s, plus 18 equals 0. So same thing, we don't want to see the bracket. We are going to expand the bracket in order to collect the like terms. So 4 times 5 is 20. 4 times s is 4s. Then minus 22 minus 10s. Minus 6 plus 6s. Then plus 18 equals 0. Then we are going to collect the term, like term s. You will see 4s minus 10s plus 6s give us 0 times s. Then move the numbers to other side. 20 minus 22 is negative 20 plus 22 plus 6 minus 18. Then you will have 0 times s equals 0 equals 10. Negative 10. So 0 times s equals negative 10. Then you will see 0 times anything give you 0. So 0 equals negative 10 is impossible. So what it means, no s will satisfy this plane. So it means that the line is not in the plane. If we find this is not 0, but we have the s value, it means we sub back, we have a point of intersection. It will be the point is intersect with a plane at one point. The line intersect with a plane at one point. And this one s doesn't exist, it means it's parallel. It's parallel with a plane. So it's not in the plane, but it's parallel with the plane. So no point of intersections. And example 3, it asks you to sketch it, graph it. How to graph it is similar with what we have done for the line. We want to find the intercept. So for this one, we also find the x-intercept, y-intercept, and z-intercept. So for the x-intercept, we are going to let y and z equal 0. At x-intercept, y equals 0, z equals 0, then just get rid of the yz, only x left. And solve it, we have 3x, move it to other side, equals 18. Then move the 3 to other side, we have x equals 6. So we have the x-intercept is 600. And to the y-intercept is x and z equals 0. So sub in, we have negative 2y minus 18 equals 0. Then negative 2y equals positive 18, bring the negative 2 to other side. y is -9. So y-intercept is 0, -9, and 0. The z-intercept is x0, y0. Subbing, we have 0 minus 18 equals 0, so it doesn't exist. Doesn't exist, so no z-intercept. Then how are we going to graph it? We are going to draw the x, y, then we hold our hand, the finger from x to y, wrap it. The sum will be our z direction, okay? So the 60 is not in scales, 6, 0, 0, and for the y is going to the left. So this is 0, -9, and 0. So the plane pass through these two, then we are going to graph it. So it's kind of, we have this 2, then it will parallel with the z direction. So this is the plane. So it keeps going, okay? So this is a plane, then it's done. So no z point of intersection, it means it's parallel with the z direction, okay? It's vertical. And go back and check what we have covered for today. So we have covered for today is find the point of intersection or intersection of a line and the plane. 3 possibilities: 1 point of intersection, infinite point of intersection, and 0 point of intersection. So we want the plane in the Cartesian equation form. If not, then we are going to use A cross product with B to find the normal, then use 1 point on the plane to sub into the Cartesian equation, find the D, then we have the equation of the plane in Cartesian equation. The reason why we want to have it in this way, because then we can sub in x, y, z from the parametric equation for a line. Once we sub in, we switch this equation to a linear equation with only one variable, we are able to solve it. If the variable has a solution, it means it has a point of intersection. And if it doesn't have the solution, it means the plane is parallel with the line is parallel with the plane. If here the right side is 0, any x value will satisfy this equation. It means the line is on the plane. So it has infinite. Any x will work, give you infinite number of points. And how to graph it? We want to find x, y, z intercepts. For x-intercept, yz equals 0. So on the x-axis, y0, z0, sub in, then we solve for x. This is our x-intercept. And y-intercept, if no z-intercept, it means the plane is parallel with the z-axis. So that is all for today's lesson. The check your understanding assigned work is on D2L under quizzes. So thanks for watching.